Hello friends, welcome to chemistry classes by Vijay Kumar Sethi. We were discussing class 11th chemistry unit 1, some basic concepts of chemistry, and in this video we are going to discuss about scientific notation, significant figures, rounding of figures and dimensional analysis. First come to the scientific notation. This is also known as exponential notation. In this, any number is expressed in this form, n into 10 raised to the power n, where this small n is an exponent having positive or negative values, and this capital N is a number, and this is also known as a digit term, which varies between 1.000 and so on and 9.999 and so on. For example, 232.508 can be written in scientific notation in this way. In this way, this decimal we have to shift two place on the right hand side. That's why we have written 2.32508, and in the exponent form, that is what is the power of 10. Then two place left side. Okay, that's why this is 10 raised to the power 2. Now come this 0.00016. In this way, we have to shift this decimal to fourth place of right side. Fourth place of right side. That's why this is 1.6 into 10 to the power minus 4. One thing you have to remember, if decimal point is shifted to the left hand side, the power of 10 will increase of that place. The same way, if decimal place is shifted to the right hand side, then this power of the 10 will decrease. Is it clear? Now, if any mathematical operation is there, then how can we use this scientific notation? So first we'll discuss about multiplication and division. This is 5.6 into 10 to the power 5. This is one number, and another number is 6.9 into 10 to the power 8, and we have to multiply these two numbers. I think you are familiar with such type of operations. Now in this case, this power 10 to the power 5 and this 10 to the power 8. Now powers of these 10 will be added. That's why we can say 10 to the power 5 plus 8. Okay, and this multiply 5.6 into 6.9. Then we will get this 38.64 into 10 to the power 13. Now again in scientific notation, this decimal we have to shift one place to the left hand side. That's why this power is increases by 1, and we will get 3.864 into 10 to the power 14. Now in case of division, this is your question, that you have to divide this number. Then again 2.7 is divided by 5.5. You have written like this, and these powers, when this denominator will go in the numerator, then we will subtract this exponent of 10 which is in denominator. That's why we'll get 10 to the power minus 3 minus 4, and this minus 3 minus 4 is equal to minus 7. Okay, and divide this, we will get this one. Now again in the scientific notation, this decimal we have to shift one place of right hand side. That's why this power is decreased by 1, and this becomes 10 to the power minus 8. Now in case of addition and subtraction, numbers are written in such a way that they have the same exponent. See the example, 6.65 into 10 raised to the power 4, and we have to add 8.95 into 10 to the power 3. Now in this case, this is 10 raised to the power 4 and this is 10 to the power 3. Now what we will do, we have to change these exponent into the same exponent, that is same power. You can change this 10 to the power 4 into 10 to the power 3, or you can change this 10 to the power 3 into 10 to the power 4. Now I have changed this 10 to the power 3 into 10 to the power 4. When this is increased, power is increased by 1, then what is the shifting in decimal? This decimal shift one place to the left hand side. That's why we will get this one. Now this among these, between these two numbers, 10 to the power 4 is common. Then you add 6.65 plus 0.895, and then we will get this one. Okay, now in the same way subtraction is there. 2.5 into 10 to the power minus 2, and we have to subtract 4.8 into 10 to the power minus 3. Make either this minus 2 into minus 3 or this minus 3 convert into minus 2. I have changed this minus 3 into minus 2. Now this minus 3 to minus 2. This is power is increased by 1. Here power is increased by 1. That's why this decimal shift to one place to left hand side. That's why this will. And now again in this number and this number 10 to the power minus 2 is common. That's why this is 10 to the power minus 2, and you can subtract 2.5 minus 0.48 and you will get this number. Significant figures. Every experimental measurement has some amount of uncertainty associated with it. Now why this is uncertainty? Because of a limitation of measuring instrument and the skill of the person making the measurement. For example, mass of an object is obtained using a platform balance. That is balance, you can say that is at the railway station or at the bus stand. Okay, if you weigh any object using this platform balance, and if it comes 9.4 gram, and again if same object is measured by the analytical balance, then this mass obtained is 9.4213 gram. That's why we can say the digit 4 placed after the decimal in the measurement by platform balance is uncertain. That's why this digit is uncertain, and this uncertainty can be represented like this: 9.4 plus minus 0.1. It means this 0.4 may be in between 0.5 and 0.3. We can say this number may be between 9.3 to this is 9.5. You can say this last digit, this is the uncertain. Okay, and uncertainty of plus minus 1 in the last digit is always understood. The uncertainty is also indicated by mentioning the number of significant figures. Now what are these significant figures? Significant figures are meaningful digits which are known with certainty plus one which is estimated or uncertain. And there are certain rules for finding out the significant figures. All non-zero digits are significant. For example, 6.9 has 2 significant figures, while 2.16 has 3 significant figures. As 0 becomes significant in case it comes in between two non-zero digits. Okay, between non-zero digits, if any 0 is there, it is significant. For example, 2.003, it has 4 significant figures, and 4.02 has 3 significant figures. You have to count the digits. This is 1, 2 and 3 digits. That's why 3 significant figures. But zeros at the beginning of the number are not significant. For example, 0.002 has only 1 significant figure. These numbers are not considered as a significant figure. In the same way, 0.0045 has only these 2 significant figures. These zeros are not considered as a significant figures. Zeros at the end or right of a number are significant provided they are on the right side of the decimal point. For example, 16.0, it has 3 significant figures because this 0 is first thing at the end of the number and after this decimal. That's why this will count as a significant figure. While 16.00, it has the 4 significant figures. Some more rules. Terminal zeros are not significant if there is no decimal point. Okay, for example, 100, it has only 1 significant figure, this one. These zeros are not considered as a significant figure. But if you write this is 100 and this is the decimal, it has 3 significant figures. In the same way, this is 100.0, it has 4 significant figures. Such numbers are better represented in scientific notation. That's why 100 can be represented like this: 1 into 10 to the power 2. It has 1 significant figure. This exponent term is not considered for counting the significant figure. 100 can also be written like this: 1.0 into 10 to the power 2. It has 2 significant figures. 100 can also be written like this: 1.00 into 10 to the power 3. That is 3 significant figures. In exponential notations, the numerical portion represents the number of significant figures. For example, 0.00045 in scientific notation, we can write this 4.5 into 10 to the power minus 4. Once again, try to understand. 4.5. This decimal is shift to right side, fourth place of right side, fourth place of right side. That's why 10 to the power minus 4. The number of significant figures in this number is 2. That is, these two digits will be considered as a significant figure. And Avogadro number, as we know, 6.022 into 10 to the power 3. It has the 4 significant figures. The decimal point does not count towards the number of significant figures. For example, this number, that is 3, 4, 5, 6, 0, 1. It has six significant figures. This is 1, 2, 3, 4, 5, and 6. Now, if you write this, this is the decimal, this is a decimal, in this case, this decimal. All these have the same number of significant figure, that is 6. Counting the number of objects, that is counting number. Counting the number of objects. For example, 2 balls. Number of balls are 2. Now, in this case, we can say that the no uncertainty. 2 ball means 2 ball. 20x have infinite significant figures, as these are exact numbers and can be represented by writing infinite number of zeros after placing a decimal. That is, 2 can be represented like, and 20 can be represented like this. That's why such exact numbers have infinite number of significant figures. Retention of significant figures, rounding of figures. The rounding off procedure is applied to retain the required number of significant figures. If the rightmost digit to be removed is more than 5, the preceding number is increased by 1. For example, 4.317. Now, in this case, we have to round up to the 3 significant figure. That's why we have to write number in 4.31, but last digit is 7. This is more than 5. That's why this is increased by 1 and this will come 4.32. If the rightmost digit to be removed is less than 5, then preceding number is not changed. For example, 4.312, we have to remove this number and this is less than 5. That's why rounding off is 4.31. But if rightmost digit to be removed is 5, then preceding number is not changed if it is an even number, but it is increased by 1 if it is an odd number. For example, 8.375 is rounded off to 8.38. You can say this last digit is 5 and before it 7 is an odd number. That's why this is increased by 1, 8.38. And this is 8.365. We have to remove this 5. And before this, this is a even digit. That's why there is the no change. Precision refers to closeness of various measurements for the same quantity. Closeness. Okay. Now, what is accuracy? This is the agreement of a particular value to the true value. With the help of one example, we will try to explain it. For example, if the true value for a result is 2.00 gram, and if 3 students are asked to perform that experiment or that measurement, and each student performed measurement twice, that is 2 times. Student A measure 1.95, 1.93, and its average is 1.940. If we consider these two, I think they are very close, 1.95 and 1.93. That's why we can say these values are precise. But this average result is not equal to true value, that is 2.00. That's why we can say this is not accurate. The same way, student B 1.94 and 2.05 and average is 1.995. Now again, if we see these two measurements, there is a large difference between these two values. That's why we can say values are not precise. But if we make the average of these two, this is very close to the 2.00. That's why we can say values are accurate. But such type of measurements are not accepted because the result which is accurate, it must be precise. Is that clear? Now see, student C 2.01 and 1.99. Again with the less difference, we are very close to each other. That's why this result or these values are precise. At the same time, if we take the average, this is equal to true value. That's why this is precise as well as accurate. Now, how can we perform the mathematical operation using significant figures? In case of addition and subtraction, the result cannot have more digits to the right of the decimal point than either of the original numbers. With the help of example, you try to explain it. 12.11 plus 18.0 plus 1.012. If we add, we will get 31.122. But we have to round off according to this rule. That is, result cannot have more digits to the right of the decimal point than either of the original number. We can see in this case there are the 2 digits after decimal. There is 1 digit after decimal. There are 3 digits after decimal. In this case, we can say this number has least digit after decimal. That's why the final result is rounded off up to the 1 place after decimal, and that's why we will get 31.1. Now, in case of multiplication and division, in these operations, the result must be reported with no more significant figures as in measurement with the few significant figures. Take the one example, 2.5 multiplied by 1.25, you will get this one. Now, this has 2 significant figure and this has 3 significant figure. We can say this has the least significant figure. That's why final result must contain 2 significant figure, and that's why this is rounded off to 3.1. Dimensional analysis. The method used to convert units from one system to other is called factor label method or unit factor method or dimensional analysis. That is, by using this method we can convert the one system of unit to the another system of unit. Okay, and for this purpose you have to know the some relationships. These are the some relationships are given. That is, 1 inch is equal to 2.54 centimeter. 1 angstrom, okay, this is angstrom, 10 to the power minus 10 meter. 1 mile, 1.609 kilometer. 1 pound, 453.6 gram. 1 calorie is equal to 4.2 joule. 1 arg is equal to 10 to the power minus 7 joule. And 1 atm, actually this is the unit of measuring pressure, and this is equal to 101325 Pascal, or we can write 1.01325 into 10 to the power 5 Pascal. 1 atm is also equal to 760 mm of mercury, millimeter of mercury. 1 bar is equal to 10 to the power 5 Pascal, and 1 atm is equal to 1.01325 bar. And this is the volume. 1 liter is equal to 10 to the power 3 centimeter cube, and that is equal to 10 to the power minus 3 meter cube. Now, see some example. A piece of metal is 3 inch. Okay, inch can be represented like IN long. What is its length in centimeter? Now, using dimensional analysis, as we know, 1 inch is equal to 2.54 centimeter. And now, this relationship can be written like this. 1 inch is divided by 2.54 centimeter, and this is equal to 1. And you can also write 2.54 centimeter divided by 1 inch, and both these terms, this one and this one, both are equal to 1. That's why these two terms are known as unit factors. Clear or not? Now, 3 inch, we have to convert 3 inch into the centimeter. Then this 3 inch is multiplied by which unit factor? By using that unit factor which cancel out this inch. That's why we use this unit factor. Okay, so this 3 inch multiplied by 2.54 centimeter divided by 1 inch is equal to, this inch is cancelled by this inch, and that's why 3 into 2.54 centimeter is equal to 7.62 centimeter. Okay, student. See one more example. A jug contains 2 liters of milk. Calculate the volume of the milk in meter cube. In a very simple way, we have to convert liter into meter cube. Now, what is the relationship between liter and meter cube? As we know, 1 liter is equal to 10 to the power minus 3 meter cube. And from this relationship, we can find out the unit factor. That is, 1 liter divided by 10 to the power minus 3 meter cube is equal to 1. In the same way, 10 to the power minus 3 meter cube divided by 1 liter, this is also equal to 1. Now, 2 liter is equal to, now out of these 2 unit factors, which we will use, which cancel the liter. That's why we will use this one. So, this 2 liter is multiplied by this, and this liter is cancelled by this liter, and we will get this one. Okay. How many seconds are there in 2 days? Very simple. But how can we use dimensional analysis for this conversion? As we know, one day is equal to 24 hours. That's why for this relationship we can find out the unit factor of these two. Okay, and again hours will be converted into the minute, and as we know 1 hour is equal to 60 minutes, and for this unit factors are this. And again we have to convert minute into second, and as we know 1 minute is equal to 60 seconds, and unit factors for this is this. Okay, then 2 days equal to, now we are having the three relation 1, 2 and 3. Now which unit factor we will use? Okay, 2 days we have to cancel day, that's why from this we use this one, 24 hour divided by 1 day. Okay, now we have to cancel the hour, that's why we will use this one. Okay, we will written this hour is cancelled by this hour, this day is cancelled by this day. Now we have to cancel the minute, that's why we will use this unit factor. Okay, this minute is cancelled by this, and then if you multiply it by this will come in the second. Is it clear, students? Subscribe my channel to get the new video. Thank you.